Okay, so what we're going to look at today is a new feature in C#8, which is the strangely named Null Forgiving Operator. We've already had the Null Propagating Operator and the Null Coalescing Operator, and now we've got the Null Forgiving Operator. And it's all related to the big new feature in C#8, which is nullable reference types. So if you're not familiar with those, you might want to take a look at my earlier video, which went through the basics. But for now, we're going to pick up where that left off and start looking at some of the other issues related to that. So what we've got here is exactly where I left off last time. So I've got a motor car, and a motor car has a driver and an engine, but the driver is optional, so that's a nullable person reference, whereas the engine is non-nullable, so we just leave it like that. So a motor car must have an engine, but it may or may not have a driver. And then we made that work by putting in here the test to make sure that we actually did have a driver. So if we missed that off, then we got the warning there saying driver may be nullable, therefore we shouldn't access it without first checking whether it's null. We don't get that same check on engine because engine we know is not nullable, and therefore there's no need for that. And so that's what we had to put in there. And that, by the way, is what I was mentioning earlier. That is our null propagating operator, the question mark dot, and then the double question mark is our null coalescing operator. Those have been around for a little while, but they're very useful when you've got nullable references. The thing is, though, we don't have to use that as the way we check our driver for null. We could equally have done something like this. We could have simply said if driver does not equal null, and that's enough for the compiler to be happy with what's going on. So I could now just assume that the driver has a name, and then just complete that, else return no driver. And that's going to be perfectly happy. So the compiler can see we've already tested it, so it's not going to give us a warning at that point. If things get a bit more complicated, however, we might do something like this. We might say if driver doesn't equal null and underscore driver dot name doesn't equal blank. Notice we don't have to check the name itself for null, because if we look at our person, string is not nullable, so we know for sure it can't be null. So we only need to check the driver and then the name. And again, we can see that's working okay. But as soon as your if gets a little bit complicated, you might think you want to tidy up the code by putting that somewhere separate. So we might have maybe a private static bool is valid, and that could take a person has a nullable reference, and then we could essentially put exactly that code in there. Get rid of the underscore. And then in here, we could say simply if is valid underscore driver. And logically, that is doing exactly the same thing. But the compiler is no longer happy. It's now saying driver may be null. The reason being, although when we had all of the tests directly in the if statement there, the compiler could see what was going on, as soon as we move it out to a separate function, the compiler can't look inside that function, and therefore it doesn't know that we've checked that driver is not null. And although you could suggest maybe the compiler could look in there, in a more general situation, that is valid method could be in a completely different class, even in a completely different DLL. So there's no real way that the compiler could have a look. And so that's where the null forgiving operator comes in. It's useful in situations where we, the programmer, know that something isn't null, but that the compiler can't work it out. And all we have to do is put in an exclamation mark at that point. So there's the exclamation mark. That's the null forgiving operator. And that essentially tells the compiler, we know what's going on. Don't worry about this. We've got it right. In a sense, it's a bit like a typecast. If you try to, for example, assign a double into an int, the compiler doesn't like it. But if we know it's going to be okay, we can use a typecast and the compiler just doesn't complain. But we may get runtime errors if we've made a mistake. Same thing happens here. By putting that exclamation mark on there, we are simply saying to the compiler, don't worry. And that does mean potentially, if we'd got things wrong, that at runtime we could introduce a null reference exception. So you've got to be careful with it, but it does at least get rid of the warnings when we know what's happening. If we take a look at this code, it's actually possibly a little bit familiar, because out in the program, I've put together another function called display text. And what happens in display text is it's got the text as a nullable reference. So it tests whether that's null, tests whether it's blank, and then either displays, in this case, the uppercase version of it or not. And so we can see that that's going to work okay. At the moment, I'm passing in a non-null. And so that just gives us the uppercase hello. Or if I were to pass in null, then that will go to the other branch of the if. And so we say the string's empty or not. But again, because this is such a common thing to want to do, to check whether a string is a null reference and then check whether it's empty, there's already a method provided for that. We've got string dot is null or empty. So we could put that on the text. We want to put a not in there, and that's doing the same thing. But the thing to notice is it's not here worrying about the fact that text could be null. When we did this for ourselves inside the motor car, remember, if I didn't put the null forgiving operator on there, it starts saying, well, maybe the driver could be null, but it's not doing it here. And the reason is that the is null or empty method has actually been slightly rewritten in standard 2.1 in C#8 to take account of this. So if we now look at the definition of that, we can see a couple of things. One is it's been changed to take a nullable string reference, which is fair enough. But then the other thing, we've got this attribute, not null when and false. And this attribute has been designed precisely to deal with this situation. So we're saying that if this function returns, and in this case false, then that means that we can assume that the value is not null. So not null when false. So if I go to my code in our motor car, I can do the same thing. I can put on there not null when, get hold of the namespace, and then in there we're just going to put, in this case, true, because it's returning is valid, so we've got a not null when true. And now you can see that we don't need to put the null forgiving operator on there at all, because the compiler can now look at it as valid and make out that this is going to be okay. So actually, although that's quite a neat example originally of where you might want to have the null forgiving operator, actually there's another way around it, which is rather better, because now we're in much safer territory. We're not telling the compiler we know what's going on. We've set it up so the compiler can understand. That said, though, if this function were out of your control, if it had already been written in another DLL and you didn't have access to the source code, and it was an old DLL, or they'd forgotten to put the not null when in, then in that case you would still need to use your null forgiving operator. One other big area where we need to use the null forgiving operator is in situations where we're using tools that are automatically mapping data onto an object, not via its constructor, which is the way we should try to do it whenever possible, but via its properties. And there are various tools that do this, but probably the most widely used one is Entity Framework. So what I've done is in here in Entities, I've reproduced this motorcar structure, but with a few changes to make them work as database entities. So you can see what I've done. I've given the motorcar an ID. I've also given it a model name just as a string. And then we've got our nullable person and our non-nullable engine. The engine, only change I've made there is give it an ID. And then the person, I've given the ID and the name. And then also, and we'll see why this is useful later on, I've said a person can have a license, so a driving license of some kind. And then that notice is non-nullable. So although a motor car may or may not have a driver, the driver, if they exist at all, is definitely going to have a license. And then the license itself is just got an ID and a description. And then I've created a DB context that's got all of those in there. And then I've just done this populate, which recreates the database. And then we have one motor car with an engine and a driver, and the driver has a provisional license. So if we just activate that and then run it up, it'll take a moment or two because it's got to generate the database. And we can see we just get the data output. That's what the program was doing. But the key thing to do is if we take a look in the database, we can see there's our car, our engines, and that sort of thing. If we look at cars and look at the design of that, we can see that it's got the model as a string, and then we've got foreign keys for the driver ID and the engine ID. But the clever thing that it's done, simply because in our code in here, we'd specified that driver is nullable and engine isn't, it's worked out, therefore, that the foreign key for the driver has to be a nullable int, whereas the engine is non-nullable. And then if we could say our people, we can also see there that the people has a foreign key into the license, which is not nullable because I'd said that that license was a non-nullable reference. So it's quite clever in terms of that. It can work out what to put in the database when it does the code generation based on what we've put in the C#. So that's a really nice feature of nullable references. However, we still are getting quite a few warnings in all of this, all related to issues around nullability. The first one to take a look at is in the DB context itself, because we can see here that all 4 of these DB sets are giving us warnings about them being uninitialized, and therefore there are problems. Because as that stands, it's as if, in fact, we had set each one of those to null, because that's just the default for a reference type. But the problem is, DB set of person we've declared as a non-nullable reference. There's no question mark in there. And the reason we can do that is because all of those DB sets are automatically filled in by the entity framework tools when the DB context is created. So it's not actually a problem that those are null because it'll all be sorted out for us, but it is a problem in terms of the compiler. Now we could say, well, these are just warnings, so why don't we leave them like that? But that's not very nice. So this is another situation where we can use our null forgiving operator, because what we do here, we say equals, we don't say equals null, but if we follow that with the null forgiving operator, remember what we're saying there is simply forget all the rules, and so now it's perfectly happy. So what you will see very, very commonly when you're dealing with entity framework and you've turned on nullable references is things like this. We initialize to null exclamation mark, and we can see now that that's perfectly happy. Now let's look at some of these other warnings. We're getting, for example, here on our person, a couple of issues. We've got the problem that name is uninitialized and license is uninitialized. Exactly the same thing because they're non-nullable. And so in both those cases, we need to put equals null exclamation mark. And again, that just gets rid of the warnings. Same thing on there, our string for model and our engine. Don't need to do it on the driver because the driver is nullable. And then our description, again, same thing to do there. So put that on there. And then we've actually only got the one error left. And this is a bit of a nasty one because what we've got here is I've got this display all, and we can see what display all is doing is goes through all the cars, prints out the driver's name if there is one. That's perfectly sensible because the driver may be null. Then we print out the car model. That's okay because we know it's definitely going to have a model. We know it's definitely going to have an engine. And then we are printing out the driver's license description. Driver is nullable, so we have to put the question mark. But license is non-nullable and description is non-nullable, so we don't need to worry about that. So those checks are all okay. But the other thing we have to do, remember, in Entity Framework is when we're traversing joins between tables, we've got to use eager loading and put that in. So when I get the cars, I've got an include of c.engine, and I've also got an include of the driver and then of the driver's license. And that's all working okay. We saw when we run this that we are getting the driver and the engine and the driver's provisional license. So it is working, but the compiler is still complaining about it because it's telling us driver may be null. But it's a bit odd this because when you write an include and you say something like c.driver.license, that code is never going to be executed. The purpose of that code is so that Entity Framework can use reflection to look inside that and determine that you're interested in a driver's license, and therefore generate the appropriate SQL, generate the join to make that work. So we've got this syntax not because we're actually dereferencing the driver, but because we're indicating to Entity Framework that it needs to write a join. And so this is exactly the sort of situation where we put in our null forgiving operator, because we're saying we know what's going on here, you don't need to worry about that, and so that just keeps it happy, even though that code is never actually executed at all. So we've got there a few situations where we use the null forgiving operator. We saw one where we can actually get over it fairly easily by using the not null when attribute. We saw a very common one where we set various things just to initialize them to null exclamation mark, and then we saw it in here where we need it for our include so that we can say that we want to pull in the license. That, however, leads on to a big conceptual issue here. If we look at our car, we are saying very clearly that a car must have a model, may have a driver, and must have an engine. And in logical terms, that's a perfectly reasonable thing to say. But when you're dealing with databases, we have this idea of eager loading for a very definite purpose. If we didn't have eager loading, we might have the situation where as soon as we loaded in the motor car, we would automatically load in the driver, and therefore as soon as we loaded in the driver, we would automatically load in the license. And if the license had any further references, we'd load those all in, and eventually we could potentially pull in the entire database in the one go. So the purpose of that eager loading is to tell us exactly what we want to pull in a particular situation. So for example here, if I've got a situation where I'm not interested in the engine, I'm only interested in the driver, then I just do an include of the driver, not an include of the engine and the driver's license. So very deliberately, it's entirely up to us what gets pulled into memory. But that means that in this case, I am actually breaching the rules that I've set up. So if we just focus on that display driver, so we won't call the display all, we'll just go to the display driver, put a break in there, run up to it. And if we look at the car, we can see the car engine is null, even though engine was a non-nullable reference. So we've broken the rules of it being null, but we've actually done it for a very sensible reason. You don't always want to pull in every bit of data from the database. So although conceptually a car always has an engine, and that means in the database, quite correctly, the engine ID column should be non-nullable. But when it comes to our program, for practical reasons, because we don't want to load in too much data, it's also perfectly reasonable that we should have the engine as null. And that kind of begs the question then, well, when we're writing the code here, should we be expressing that as a non-nullable reference, even though we know sometimes it is going to be null? Or should we just say all of our navigation references are going to be nullable, because depending on how you load them in, they may or may not be null? And that's something that's not really resolved as yet. So I'm not sure exactly the best way to go with that. For now, I'm kind of sticking to trying to express my meaning and living with the fact that if I don't eager load them, then they will be null. But it may be that future editions of Entity Framework solve that in a rather better way. But there we have it, the null forgiving operator. So simply an exclamation mark that we put after an expression of a nullable reference type to tell the compiler that we know what's going on better than it does and that it shouldn't apply any of the checking rules. If we can code in a way that avoids it, then all the better, but just occasionally it will get us out of a real bind, particularly with those initializations to null exclamation mark. Any questions? Pop them in the comments below, and I'll see you next time.